As a review, before we get to the more complicated integration strategies, we are going to go back and do so-called basic examples that use the original rules of integration, namely things like power rule, the trigonometric rules, and U substitution. So we're going to start with these 4 examples. Okay. When trying to do this integral, it looks originally like some kind of power rule, or product rule, because there is this product. But when you're looking at something that looks like a product, the first thing you should always try is a U substitution. And we let U be what looks most inside in the problem. So I'm going to let U be x squared, then du would be 2x dx. Now what I'm looking for is that most of this is present in the problem. And what I have is x dx. So I'm going to move the 1/2, the 2 over as a 1/2, basically solving for what I actually have in the problem. Going back to this then, the x dx becomes 1/2 du according to the substitution, and the sine x squared becomes sine of u. Now I can use a very basic rule that says that the antiderivative of sine is minus cosine. Okay. The half comes down for the ride, and of course with any integral we put the plus c afterwards. For our second one, we look at it, we see a secant times a tangent where they have the same argument for both of them. So this looks an awful lot like a straight up trig function, except for the fact that this is not x. So I'm going to do a little bit of a U substitution. It's actually, you can actually skip this and you'll see later on how to put it in the end. But there's no harm in doing it. This gives you du is 5 dx. I don't happen to have the 5, so I move it over to the other side. Going back to my integral then, this becomes secant u, tangent u, and 1/5 du. Okay. Secant tangent is the derivative of secant, so this just becomes 1/5 secant u plus c. Okay. And we actually realized we forgot on this one to undo our substitution. You have to plug back in the fact that u is x squared. Just like I have to undo my substitution on this one, I have to plug back in the fact that u was 5x. So you'll notice I could have actually skipped the entire u substitution, recognizing that this is going to give me some kind of secant with the 5x coming from here, and then we just would divide by the derivative of that inside, since I'm taking an antiderivative. Okay. For our third example, again it looks like some kind of product rule, but we're always going to try a u substitution first. And of our choices of what can be u, we want to go for the thing that's inside. And this sign is inside the exponential. So I'm going to let u equal sine x. Then du would be cosine x dx, which I happen to have. So my integral then becomes e to the u du. The antiderivative of e to the u is, of course, e to the u plus c. And then once again, I undo my substitution to get my full antiderivative. For my last one, I look at this, and this looks an awful lot like some kind of inverse trigonometry. Okay. In actual fact, it is inverse hyperbolic trigonometry. So I'm going to be using a formula. Okay. According to the formula, u is x, a is 2. Okay. And then my antiderivative is minus 1/2 ln of the absolute value of a plus the square root of a squared minus u squared all over the absolute value of u. Okay. There really is no simplified way of getting that. You simply want to have access to the formulas for both the standard inverse trigonometry as well as the hyperbolic inverse trigonometry at all times.